This is problem number 3 from the collision problem set. So I told you I'd like to draw pictures. So here's my picture. I have an ice hockey player. Oops. And he weighs 900 newtons. Okay. So here's my hockey player. He's on his skates. Those are skates. They're holding their stick, right? And so he weighs, his weight is 900 Newton. Now, remember, weight is not mass. And I gave you a way to figure out mass from weight. And if you didn't write this down before, write it down now. The weight of someone is equal to mass times gravity. So if someone had a weight of 900 newtons, okay, if I wanted to know their mass, oops, I don't know what happened there. If I wanted to know their mass, I would times that by 9.8, right? So if I'm doing the algebra, 900 equals m times 9.8. I want to get rid of the 9.8, get m by itself. So you'll divide. And can someone tell me what 900 divided by 9.8 is? Oops, I put 9, I meant 90. It's going to be like 91.8, thank you. So the mass is 91.8 kilograms, okay? So player number 1, he has a mass of 91.8. Now this would kind of be like your blow dart. This player is like your blow dart, and you knew the mass of the blow dart when you set it off. Now he's skating with a velocity of 8 meters per second. So once again, in that simulation that we looked at, the blow dart, you could figure out the velocity by measuring the distance and getting the time. All right? So you know the mass, you know the velocity. Now there's another player from the other team. He's just sitting still. So there's the other player. Okay? Their velocity is 0 meters per second. Their mass is unknown. So I start out with player 1 and player 2. Now, they slam into each other. So at that point, you know, the two players, they become tangled up, and they're kind of like one jumbled player, okay? Their new velocity is 5 meters per second. And then their mass, because they're together, it'll be 91.8 plus a mystery mass. So this problem is actually harder than your blow dart problem, but like this player is like the blow dart, this player would be like the cart. And then the blow dart and the cart, they stuck together and they moved together, all right? In your lab, you didn't know the velocity, but you knew the masses. Here we don't know one of the masses, but we know the velocity. So I need more space. I'm going to clone this page, and I'm going to delete some of the stuff from it. Okay, so the part I'm going to delete is this down here where we figured out mass from weight. Okay, so now in this problem, this is like any other collision momentum problem. I'm going to take m times v for every object before they collide, and I'm going to set it equal to m times v for every object after they collide. So I'll get 91.8 times 8 plus my mystery mass times 0. That has to equal 91.8 plus my mystery mass times 5. Okay? Can someone tell me what 91.8 times 8 is? Okay, here we go. 734.4. So I have 734.4. 734.4 plus 0, that's always just going to be the same thing. So do you see this term right here? It's just going to go away, right? And then so that's going to equal 91.8 plus m times 5. Now from math, I'm sure you remember this. If something's in the parentheses, you've got to distribute it. So what's 91.8 times 5? Can someone tell me that? 459. And then 5 times m, that will be 5m. Okay? So the hardest part of this problem, you guys, besides just writing out the scenario, would be the math part of it. So I got to get rid of this 459. It's being added. So I'm going to subtract it from both sides. These will go away. And 734.4 minus 459, what does that equal? $275.4. So that equals 5m, right? Because that canceled out. Now I got to get rid of the 5, so I divide both sides by 5. And I get the mass is going to equal 275.4 divided by 5. That will be 50 what? 55.8? Is that right? 55.08, sorry. 55.08 kilograms. So that would be his mass. Now this was one of the hardest problems on here, but it was similar to your lab. Your lab was actually easier because you knew m plus v for the blow dart, you knew m plus v for the cart, and then you had to set that equal to m times v for the combined, and you were given the m, you just had to calculate v. Okay, here it was a little harder because we had to distribute the 5 in those parentheses. Okay, and so someone asked me then if I could do number 5. Okay, so number 5 actually has to do with number 4. So for number 5, it says, suppose that in the previous problem, I have a Volkswagen moving at a speed of 120 miles per hour and the Cadillac moving at a speed of 120 kilometers per hour and 15 kilometers per hour. So I make you convert these, all right? Actually, just to make this problem easier for right now, we're never going to do this on the test, but let's just leave these in kilometers per hour instead of meters per second. So I have these two things, and they collide head-on and lock bumpers. So they're moving towards each other. So I have a Volkswagen. That'll be my Volkswagen. I have a Cadillac. That'll be my Cadillac. And they're moving towards each other. I don't know if it says that in the problem here. Nope, it doesn't. But it does in the last problem. It gives me the masses. So the Cadillac is 2,500 kilograms, and the Volkswagen is 1,000. So the mass of the Volkswagen is 1,000 kilograms. The mass of the Cadillac is 2,500 kilograms. Okay. Now the mass or the velocity of the Volkswagen is 120 kilometers per hour. The velocity of the Cadillac, 15 kilometers per hour. So he's going pretty fast, he's going pretty slow. I don't know whose fault this is, but they're heading towards each other. Now, we actually get to decide which one of these is positive and which one of these is negative. Does anybody have a preference, or do you want me to pick? No preference? Well, what I'm going to do then is I'm going to make the one moving to the right. That would be my Volkswagen. We'll make this the positive direction, right? So that'll be the positive direction. And the Cadillac will make that the negative direction. So this velocity will be 120 plus 120, and this velocity will be negative 15. Okay, so this is what's happening before they collide. Now, after they collide, these two cars are going to lock bumpers. They're going to mangle together. And so when they mangle together, they become one thing. This is like the blow dart lab once again. So because they become one thing, their combined mass would be 3,500 kilograms. Because this one had 1,000, this one had 2,500. Their combined mass will be 3,500. Now their velocity, that's a question mark. That's what I'm looking for. So if we read the problem again, it says that the Volkswagen was moving at 120, Cadillac at 15. They collide head on. They lock bumpers. And I want to describe the motion of the two cars after the collision. Well, because they lock bumpers, they're going to be moving together. Now, if this velocity comes out positive, it means they'll be moving to the right. If this velocity comes out negative, it means they'll be moving to the left. But in all of these problems, you guys, I'm just going to look at my picture, and I'll say, okay, well, the m times v for this plus the m times v for this has to equal the m times v for this. So everything, the momentum of all of the things before they collide has to equal the momentum of all of the things after they collide. So here I would have 1,000 times 120 plus 2,500 times negative 15, and that has to equal 3,500 times my mystery velocity. So if I plug this in my calculator, this will be 120,000 plus, this one I can't quite do in my head. I should be able to. What's 2,500 times negative 15? Do I need to punch in my calculator? Oh, there we go. So it's negative, oops, that's what I thought it was, but I didn't want to make a big mistake. So it's negative 37,500. And I'm just, instead of writing plus negative, I'm just going to write minus. That means the same thing. Okay, so then I have to add these two together, 120,000 minus 37,500. That will end up being 82,500. Am I right? Can someone tell me? So I'm waiting for confirmation. Anyone? Anyone? Oh, okay, I'm right. So that's going to equal 3,500 times V. And then I got to get rid of this 3,500. And so you know that I have to divide both sides by 3,500. And I'll get V equals. Now this one, again, I can't do in my head. Oh, so actually, Haley, I got a different answer. I think that what you may have done is flip these two. I think you may have accidentally done 3,500 divided by 82,500. Yeah, so I got 23.57 or 23.6 as well. Oh, and because we never converted, remember the answers would be in kilometers per hour. Okay, so because this is positive, it means that these two cars will move to the right. And the reason that happened is because this, even though the Volkswagen was smaller, it had a lot more velocity, so it ended up with more momentum than the Cadillac. Because this had more momentum, both cars end up moving to the right. Now, we're going to talk about this on Monday, but these kinds of accidents, you guys, are really, really dangerous. And it's because the velocity changes inside these cars can be pretty big, and they happen over a really short time, which means the accelerations are really big. And the forces acting on people in these cars can be really large. And that's not good, right? It's not good to have a lot of force acting on your body. Bodies aren't built for that. So, yeah, so we'll talk more about this on Monday. So, is there another problem that you guys want to do? Those were probably the two hardest ones on the sheet. Are there any other ones that anybody struggled with? One more before we leave? Should I pick out one? Okay, let me pick out one then, I guess. And then that'll be our last one. So that was number 5. We kind of did number 4. We did number 3. Maybe we should do an explosion problem. So we can either do number 1 or number 2. Let's do number 2. All right. So in number 2, I have a gun, and it's a really, really light gun that shoots heavy bullets. Okay. So the bullets have a weight of 50 newtons, and the gun has a weight of 40 newtons. Okay. So remember, weight is not mass. Weight is mass times gravity. So mass is going to be weight divided by gravity. All right. Now, does anybody mind if I just round gravity to be 10 instead of 9.8? Is that going to bother anyone like a huge amount right now? I'm not getting any response, so I'm thinking it's okay. All right. So if I divide 50 by 10, that would make the mass of the bullet 5 kilograms. Okay, so that's the mass of the bullet. And then the mass of the gun would just be 4 kilograms. And if you want to on your test, you guys, you can round gravity to be 10. All right. Now, it says that the bullets have a muzzle velocity. They leave the gun at 200 meters per second. That's like over 400 miles per hour. So I want to know what's the velocity of the gun after I fire it. Now, remember in these explosion problems, you guys, the total momentum of the system before anything is fired, when the bullet is just sitting inside the gun, the total momentum is 0. After I fire the bullet, the total momentum has to stay 0. Okay? So what that means is the momentum of the gun going backwards is going to have to equal the momentum of the bullet going forwards. Those have to be the same. They have to be the same because they are in opposite directions. So if one is positive and one is negative, they would cancel out and be 0 still. So the mass of my gun times the velocity of my gun has to equal the mass of my bullet times the velocity of my bullet. And this could be a gun and a bullet. It could be, a person throwing a ball. It could be any time that I have like this sort of explosion, right? The momentum of one object going in one direction is going to have to equal the momentum of the other object going the other direction. So here I have 4 times my mystery velocity. That's going to equal 5 times 200. 5 times 200, if you punch that in your calculator, it's 1,000. Okay. And then I have to divide both sides by 4 to get rid of 4. And my velocity will be 250 meters per second. So that's a solution here. Now, does everyone see that my gun would actually fire faster than my bullet? If you designed a gun that was lighter than the bullet, you could probably only fire that gun one time. Because after you fired it, you would basically shoot yourself with the gun, right? And we talked about this before. This is why guns in real life are really heavy. Because the momentum of the gun going backwards has to equal the momentum of the bullet going forwards. All right? So the momentum of the gun going backwards has to equal the momentum of the bullet going forwards. I want the velocity of the gun going backwards to be really small, so I make the mass of that gun really big. Right? And then over here, I want the velocity of the bullet to be really big, so relative to the gun, the mass of the bullet has to be small. Now, the bigger the mass of the bullet is, I have to do one of two things. I either have to make the mass of the gun bigger, which is usually what I do. In some guns, I can't make the mass of it big enough to control the recoil velocity. So what you have to do instead is you can't actually fire them from a standing position. They have to be fired from, say, a tripod. So they have to be fired from a prone position, or they have to be mounted onto something. So the bigger the bullet, the more massive the gun, and there's a certain point where I can't make this mass big enough, so the gun can't even be fired from me holding it. It has to actually be mounted like in a helicopter, like a minigun, or I have to have a tripod and I have to fire it from a prone position, which means that you're laying down on the ground. So this is like with sniper rifles. If they have really large bullets, you can't fire them standing up. So does this all make sense to you guys?